welcome to the Deep Dive. Today we're taking a close technical look at some key 2025 research, arguing that large language model hallucinations aren't really some deep mystery.
Right. The argument is they're not these strange cognitive glitches, but actually statistically predictable errors.
Errors that come directly out of how we're currently training and, importantly, evaluating these models.
Exactly. It shifts the focus. We've often treated these false statements, almost like personality flaws in the AI. But this analysis suggests they stick around because the incentives are just wrong. The training objectives, and especially the evaluation methods, they implicitly reward generating plausible-sounding stuff, even if it's wrong.
Instead of just saying, I don't know.
Precisely. Acknowledging uncertainty, or epistemic uncertainty as the paper calls it, isn't rewarded.
Okay, so let's unpack that theoretical origin piece first.
Yeah.
The paper claims these generative errors, even way back at the pre-training stage, they basically start as simple errors in binary classification.
Yeah, and this is where it gets really interesting, particularly if you're into computational learning theory.
How so?
Well, they formalize this using something called the is it valid classification problem. 8-4 for short.
Okay.
They model the LLM's generation process as if it's constantly making this internal check. Is this statement valid?
Right.
And the math rigorously shows a direct link. The overall rate of generating errors, hallucinations, is lower bounded by roughly twice the rate the model messes up this internal validity check.
Wow, so double the misclassification rate.
Approximately, yes. It neatly connects the complex problem of generative error back to, well, a much better understood statistical concept, misclassification.
And that lower bound has some pretty serious implications. It means some level of error is just baked in, statistically unavoidable, even if you had perfect training data.
That's a key point.
The paper uses this arbitrary facts idea to illustrate it, specifically looking at the singleton rate in the data.
Explain that a bit.
So imagine facts that only appear once in the entire massive training set, like maybe someone's non-famous birthday or really niche historical detail.
Okay, the singletons.
If, say, 20% of unique facts are singletons, the research predicts the base model will hallucinate on at least 20% of those facts. It's not really a bug in the training process itself.
It's more like a statistical inevitability based on how sparse that information is, density estimation limits.
Exactly, even with perfectly clean data.
Precisely. So that's the origin story, rooted in statistics. But then the problem shifts post-training. It becomes what the paper calls a socio-technical issue. Meaning it's about the interaction between the technology and the social systems we use to evaluate it. Models get fine-tuned and optimized to be really good test takers.
Right, under the current rules. And the rules reward sounding confident, even if you're wrong.
That's the misalignment.
We see this structure in all the major benchmarks, the ones everyone uses. Things like GPQA for reasoning, MMLU Pro for professional knowledge, even SWE Bench for coding.
They almost all use strict binary 0-1 scoring. Correct gets a point, incorrect gets 0.
And saying, I don't know.
Also gets 0.
Ah.
So from the model's perspective, if there's any chance of being right, guessing maximizes the expected score. Abstaining never helps your score under these schemes.
Which leads to this kind of absurd situation the paper points out. A theoretically perfect model, one that accurately flags its own uncertainty every time,
would actually score lower on our main leaderboards than a model that just confidently guesses when it's unsure.
That's quite an indictment of the current evaluation paradigm. An epidemic, the paper calls it, of penalizing uncertainty.
It really highlights the problem.
So, okay, where does this leave us? What's the path forward?
Yeah.
The paper suggests it's not just about adding more specific hallucination benchmarks on the side.
No, the argument is stronger. It requires changing the primary evaluations, the big ones that actually drive the model development cycles.
And they propose a specific mechanism for that.
Yes, and it's quite elegant, statistically speaking. They call it adopting explicit confidence targets directly in the benchmark instructions.
Explicit confidence targets, how does that work?
You set a target confidence level up front, let's call it $2, maybe 90% or 95%. Then you change the scoring.
Okay.
An incorrect answer isn't just 0 points anymore. It gets penalized quite heavily, specifically a penalty of $2 divided by $1 T-points.
A specific penalty based on the target.
Exactly. The math works out so that the expected score for giving an answer only beats the score for abstaining, which is still 0, if the model's actual internal confidence is higher than that target $.
Ah, so it forces the model to be honest about its confidence level. It makes guessing costly if you're below the required confidence threshold.
Precisely. It incentivizes what they call behavioral calibration, aligning the model's expressed confidence with its actual internal state.
So the final thought for you, our listener, is this. Imagine if the major leaderboards actually adopted these kinds of explicit confidence targets with real penalties for poorly calibrated, overconfident answers.
Would we finally see models shift? A fundamental change from just being good, maybe deceptive, test takers?
To becoming genuinely trustworthy systems. Systems that actually know when they don't know and tell you so.
That's the potential strategic shift in alignment to watch for, something to consider.